So, yesterday, whatever we did, do you guys recall? Do you remember what we learned yesterday? Do you guys remember what we learned yesterday? Kind of. Okay. So we started with the area of shapes, where we talked about the area of a triangle, area of quadrilaterals. That is where we even tried proving the area of how do you derive the area of rhombus, area of trapezoid, and that is where we left. So, and you all kind of recalled how do you find the area of what is the formula for area of parallelogram also, right? So I'm not going to prove each and every formula. Probably wherever we find there's something interesting about it, we'll try proving it. Some of the things would be known to you. So just in the interest of time, we will try skimming through some of those and so that we can get to the meat of what we are trying to learn. So today we'll jump from area to volume. So before I move on, I'm assuming that you guys know area of a circle is pi r square and the perimeter of a circle is perimeter of a circle. I'm sorry. Pi 2r or 2 pi r. Yeah. So.
Hi, sir. Sorry. I.
Yes, Dhanusri. Go ahead.
I'm sorry I joined late. I lost track of time.
That's perfectly fine. So basically, we just started with a quick recap of what we learned yesterday, and we just touched upon the area of a circle and perimeter of the area is 2 pi r. I'm just going to keep that handy for everybody's recollection, so that when we go to the next topic within this same unit, which is about the volume of solid shapes, all these areas will help us. So before we move on, I will keep on asking some stupid questions, but bear with me. What is the difference between area and volume? How do you relate those? Yes, Arya.
Area is like the surface, like the entire surface of a shape, while volume is like surface and is like inside the shape of a 3D shape.
I'm pretty sure you know it. You're just trying to articulate. Okay, let's hear Prince's view also. Yeah.
Area is the amount of space a 2D shape takes up on a surface, and volume is the amount of space a 3D object takes up on space.
That's a very mathematical answer, and I mean I cannot deny what Arya said versus what Pranit said. Both are the same. What Pranit is saying is, you look at area in a two-dimensional shape, the space taken by something in a two-dimensional shape, or two-dimensional space, meaning here you're only seeing two dimensions, this side and this side. Either. So this is where we talk about the area of a rectangle, square, parallelogram, trapezoid, triangle, circle, whatnot. Yeah, or pentagon, hexagon, whatever it is. But then when you talk about a volume, so here if you talk about two dimensions, you're talking about x and y dimensions, like what you see on the board. But then if you imagine there is a third dimension, meaning if the board is having a depth also, then you can look at, then you can bring that z axis also into the picture, and that becomes a 3 dimensions. One dimension x, second dimension, and the third dimension, which is vertically above the board basically. So all of us, be it anybody in the classroom on the screen or in the here, all of us, we are all classic example of three-dimensional objects. We have length, width and height, right? So when you talk about area, you're talking about two dimensions, meaning amount of space taken by any object on the surface or in two dimensions. This has more area, this has less area. This baby rectangle has least area. I mean, takes or requires least area or is taking least area on the surface for drawing it. However, volume is the amount of space taken in a three-dimensional space, meaning if you look at or if you visualize this classroom where I'm not taking space in two dimensions, I'm taking space on the surface where I'm standing right now, which has length and width, and then my height. So that is the third dimension. So basically volume is nothing but the amount of space taken by any three-dimensional object or any solid object. Three-dimensional object is nothing but a solid object. That's what we'll call it. Okay. So volume is nothing but the space taken by any three-dimensional object in the surrounding or the space wherever you are keeping it. No denying what Arya said, what Pranit said. I'm just reiterating that in a different way. That's it. Yeah. Now, so in simple terms, volume is the amount of space taken by any 3D object in the place where you are keeping it. So if I, let's say, take certain volume, and this classroom also has certain volume, so there is a certain number of people only you can accommodate in this space. You have certain space, which is the volume of this room, and then each one of us in the classroom is taking certain space, which is the volume of that individual, and you can have only that many people. I cannot dare to have 500 kids in this classroom because the amount of space or the volume taken by 300 kids would be more than the volume this classroom has in the offering. Everybody with me so far? Everybody?
Yes, sir.
I'm pretty sure none of you will ever dare to find out the volume of a person like me. But these are relatable aspects. If you imagine me being a rectangular object with height, then you will probably calculate my volume. Otherwise, it's kind of difficult to find out my volume or any individual's volume. So we will look at some of the standard shapes that we talk about and then find out how do we find out the volume for that particular object. So let's look at, this is my rectangle. This is taking certain space. How much space it takes? That is called area. Length times width. Now imagine this having some depth also. And again, my drawing skills is questionable, but you'll have to believe me. So this is like a matchbox or a phone or whatever you see which looks like a rectangle with a height. This is called, so it has, this is my length, this is my width, and this is the height. So the volume of this object is called cuboid. Yeah. So when you extend a rectangle and add height to it, that is called a cuboid. Similarly, if you have a square and you add height to it, that becomes a cube. Yeah. In case of cuboid, length, width and height all are different. As we all know, rectangle has length and width being different. Similarly, the height also can be different or same, doesn't matter. So your volume of this cuboid will be length times width times height. Meaning, even if your length and width remains fixed, if you keep on increasing the height, you are making the box bigger. It will take or have more volume. It will take more space. Yeah. Classic example of that is, let's say my notebook. This is my notebook. If you are looking at this as a rectangle, this has length and width. Now, what I'm doing is I'm adding sheet after sheet to add height to it. More the sheets, more the height. Yeah. If I add, let's say, 200 more sheets, it will become thicker. Will have more height. So that is what determines what will be the volume, length times width, and more the height, more the volume. That is what it is here. So volume of cuboid is equal to length times width times height. Are we all on the same page?
Yes, sir.
Everybody? Dhanushi, Shravya, Neil, Sarah,
Yes, sir. Yes, sir.
Vaibhav? Yeah, okay. Now, so volume of a cuboid is length times width times height. Same way you can visualize a cube also. Cube, the main property of a cube is nothing but a square extended vertically to an extent where the height of the cube, see, in case of a square we know that the length and width are the same. Here we will call it a cube only if the height of this square is also same as the length and width, basically. Meaning length, width and height all are same. That's why I'm calling length, length and length. So again same thing, it is no different from the cuboid. Length times width times height. Here we know length is L, width is also same L, and height is also same L. So that is what becomes my volume for cube. You all would be knowing these formulas. I'm just peeling the onions, making it look easier. Are you guys with me so far? Everybody?
Yes, sir.
Alright.
Okay.
Okay. Now, so we looked at the volume part of it. That is understood. So volume for cube is length times length, or we can call it length cube, or volume of a cuboid is length times width times height. Now, what is the surface area?
Surface area is the area of each face of the 3D shape all added together to give you the entire amount of area the surface takes.
Okay. So, any other definition of surface area? Anything that you guys can think of? If you have to color me pink, okay, if you don't like my color, you'll say, okay, my teacher doesn't look good with whatever color he has, I want to color him pink. What would be the surface area? It will be the amount of the surface that is exposed, which you would actually want to color so that you don't see my actual color. Same way, if you're looking at a cuboid, we are essentially talking about when you say surface area, you're talking about all the faces that is visible from outside, which you would want to color if you need to. Yeah? So the surface, the area of the surface, it's plain simple English, there is no math here. You're saying area of the surface. Surface is what? What is exposed. So that's what is surface area. Do you guys know how to find out the surface area of this guy? This one? Cuboid. By any chance, do you remember the formula? I'm sure. One good thing, I was just reading an article on SAT. What it says is, you guys don't have to remember the formula for most of the things, okay? But then they will give you those sample formulas, and then there will be some tricky questions hidden within which you have to use for solving the problems. But you don't have to memorize the formula. So that's why we are not trying to memorize the formula. I'm just kind of trying to explain. So if you look at the surface area, right? Visualize this. Let me give you an example. This is a classic example of a cuboid. This is length, this is width, and this is the height. If you want to look at the surface area of cuboid, you are essentially looking at 6 surfaces. This one, same as this one, the back of it. This one and the opposite side, same. And then this side and the opposite side. So essentially you are seeing 3 pairs of surfaces with equal area. Am I making sense so far?
Yes.
Yeah?
Yes.
Sunarka, you are with me?
Yes, sir.
Okay. I'll just randomly call names, okay, just to make sure that everybody is with me, okay? Alright. So here, when you look at a cuboid, you're essentially talking about 3 pairs of equal surface area. This one, this one, this one, this one, this one, the back side. 6. So basically, you're talking about surface area of a cuboid as 2 times 3 surface area. Let's say this one. Let's look at this as a rectangle. This is length and the width is h. Length into h. Plus this surface area. 2 times of this one. This again has length as, let's say, w, and height, which is the width. When you look at this as a rectangle, so it will be h into w. Plus, you're looking at this one. which is length is this and width is length times width. So this becomes your surface area. 2 times of length into height plus height into width plus length into width. That's what is the surface area. You don't have to remember this. Whatever we have done so far is just to visualize that part of it. Now same way, if you look at the surface area of a cuboid, of a cube, which you are essentially seeing, this is nothing but a dice. Like whoever has played Ludo or Snake and Ladders, right? You would have seen something that we roll and which has 6 numbers written on it, right? All the 6 sides are identical squares from an area point of view. So basically here, your length, height, width, everything is same. So you can relate with this one. You can say 2 times of length into length plus length into height into width is again length into length plus length into width again same. So it becomes 2 times length squared plus length squared. So 3 length squared equals 6 length squared. You can look at it this way, or you can say, okay, fine, there are 6 shapes, 6 squares which are identical. So 6 times the area of 1 square. 6 times area of 1 square. Everybody with me so far?
Yes, sir.
Okay. Alright, so what we have seen so far is volume and surface area of a cube and cuboid. Let's look at the next one. And again, while we are doing this, we are also kind of proving or visualizing what it would be. And there is no assumption or there is no force or brutal force for memorizing it. Okay, so we are just trying to relate it. Now look at another shape that we'll talk about. What is this called? Cylinder, or there is another name. Right cylinder. Yeah. And even if these things are known to you guys, but I would still want some of you to acknowledge, so that way it gives me the comfort that yes, I'm not going way too fast or I'm not assuming anything. If you look at this guy, this is nothing different from what we saw in case of a cuboid. What we had there was, we had a rectangle like this with height added to it. Here what we see is, we have a circle at the base and there is a height added to it. Yeah? So if here what we did, area of the rectangle multiplied by height. Area of the rectangle is length times width multiplied by height. Here also we do the same thing. Area of the base multiplied by height. So this becomes volume of the cylinder is area of the base. What is the area of the base? What is the area of a circle? Pi r squared multiplied by h. This part is okay? Are we all able to relate to what I'm saying?
Yes, sir.
Okay. Alright. Now comes the tricky part. The surface area of the cylinder. Surface area. Yeah.
It's 2 circles and a rectangle.
Uh-huh.
You find like surface area of the 2 circles and then add it with the surface area of the
Yeah. So this is my cylinder. Yeah. This is the circle and this is height to it. So what we have to do is find out the surface area of this top and the bottom and the surface area of this curve that we see here. Okay. So surface area of this will be, this area is pi r square plus this area is also pi r square plus this curve that we see. So the curve, this curve that we see from here to here. Look at this. What did I do? I opened this cylinder to make it look like a rectangle. So, meaning, if I look at this as a cylinder, I'm trying to find out this curve, surface area, which has this height and this perimeter as my curve. See, the perimeter expanded to be the one side of the rectangle and the height. What is the perimeter? 2 pi r. Again, just helping you visualize this. This is your cylinder. This is the perimeter, and when I'm expanding it, I'm opening up the perimeter to be one of the sides of the rectangle and then the height. So the 2 pi r is my perimeter, which is one side. We call it length or width, whatever we want to, and the second side is nothing but the height into h. So it becomes 2 pi r square plus 2 pi r h. Now I'll just stop here for a few seconds just to see if everybody was able to visualize what circus I did here. Sivatsa understood. He has heard me before, I'm sure. Okay. Dhanushri would have understood as well because she also has heard me a couple of times. Yeah, Baba also. Yeah. Anybody who was not able to relate to what I did just now to find out the surface area of a cylinder? Heer, Savya, Arya, Atharv, Neil, Sarah.
I understand it.
You understood?
Understood, sir.
Understood. Okay. So again, I am a little boring teacher. I keep on repeating myself, but yeah, just that is with the intent to make sure that you understood this. So this was my cylinder. This was my curve. I just opened this curve to make it a rectangle. So the base or one of the side of the rectangle was nothing but the perimeter, as you could see, 2 pi r, and the height 2 pi r h. So length times width. My length is 2 pi r now, which was a circle before, which I cut it open, and then other side is the height 2 pi r h. I hope everybody is with me, right? Sarah, Neil, were you guys able to follow me?
Yes, sir.
Wonderful. So this becomes my surface area of a cylinder, which is 2 pi r square plus 2 pi r h. If you want to make it simple, 2 pi r is common, so it becomes r plus h. Any which way, I mean, either way you can remember this or relate this, up to you guys. So we have looked at the volume and surface area of cuboid, cube, and the right cylinder. Now there is one more thing, that the cuboid that I called, sometimes they call it rectangular prism also. So volume and surface area of rectangular prism will be same as the volume and surface area of the cuboid that we found out. Similarly, they can call a square prism, same thing. You can call it a cube or you can call it a square prism, up to you. Now there is one more thing that you would have seen, which is called a cone. So what is the volume of a cone? What is the volume of a cylinder? Imagine this as something that is, yes. So if your volume of a cylinder is pi r square h, just look at it visually. You have just split this into 3 parts. Okay? It'll be 1/3 of pi r square h. Am I able to reach everybody? Yeah?
Yes, sir. Yes,
Okay.
sir.
Alright. Similarly, if you have to find out the surface area of this one, does anybody remember what will be the surface area of a cone? Okay, I'll give this guy this assignment to you guys. Okay, find it out, the surface area of a cone, and if needed we can prove that in the next class also. I don't want to hijack the whole class for proving the surface area of a cone, which anyways you don't have to prove, but I'll let you guys find it out. Yeah, is that okay, or you want me to see the way you have to visualize this is this one. You have to find out the surface area of this part, which will be nothing but pi r square, and this also has a height h. So you have to look at this when you open it, right? It's a funnel. that we all use for pouring liquid, right? So you have to look at how do you cut open the funnel, what exactly does it become, okay? So it'll, when you cut it open, it'll become something like this, because when you fold it, yeah? So you have to look at, you have to visualize this as small triangles, right angle triangles, one after another for this perimeter of 2 pi r. Okay? So I'm stopping there, okay? I've just given a clue to you guys. You guys find it out, and if there's any doubt with respect to how to find out the surface area of a cone, we'll do that in the next class. Alright? Yeah? So we have essentially looked at the surface area and volume of most of the common shapes that we come across. Only thing I have kept open purposefully, because I would want you guys to also do a bit of research and let me know. Okay, I have proven this in the previous classes, and if you happen to watch one of the videos of the previous class, you'll be able to find it out, but I'm not doing that purposefully. Okay, so this is where I would stop. Let's look at what are the other topics that I had mentioned in the WhatsApp chat, and then we'll see what is done, what is remaining. So area and volume of shapes, congruence, similarity and angles, triangles and parallel lines, and then trigonometry, right triangle basics. So Katoa, yeah.
What about a sphere?
Yes.
You sphere.
So sphere, yeah. So sphere, if I try proving how the formula is derived, I would need to take you guys to the depth of calculus. But then, if you talk about sphere is nothing but a football, a ball, a solid circle. I mean, not circle, call it circle. You call it sphere, yeah, like a ball or a football, or the earth itself. You can imagine this as a circle rotated around this, revolve around this line of symmetry, which is passing through the center of this, and it makes a sphere. What is the volume of a sphere? Anybody remembers? Volume of a sphere. Okay, look at this. You have, it is actually 4/3 pi r cube. Yeah. Now, again, I'm just trying to recall if I can prove it without going to calculus or not. So this is my semicircle, which I'm revolving in 360 degrees. Yeah, no, I cannot do it without calculus. And if I have to prove this, I'll have to go back to read something for you guys. So volume of a sphere, how much amount of substance that it holds or how much space it takes is a function of this formula, 4/3 pi r cube. So that gives you the total volume of a sphere. So you have to visualize this. I mean, again, I was just giving you as a clue how it works is, this is a semicircle, and if you imagine, if you have I'm not sure if you guys have seen that, in India, during some festivals, we used to have a small fan, handheld fan, okay, which you can rotate like this. So imagine that fan being a semicircle, and that you're rotating in 360 degrees. So what is the area of a semicircle? Area of a semicircle will be pi r square by 2. Yeah, area of a circle is pi r square. Say semicircle will be pi r square by 2. Yeah, and then you are rotating that in 360 degrees. That will be the basis. So this is where you use your integration logic from 0 to 360 degrees. Okay, let me not go there. Okay, so that is the calculus part, which will be a little tricky. We need a bit of preparedness before we try solving this using calculus, but this is what you would want to kind of remember, or you don't even have to remember. If there's a question on volume of a sphere, they'll give you the formula itself. Yeah, and let me do one thing. I will try finding out. I will try finding out if there's an easier way to prove this. Okay, the volume and surface area of a sphere. Does anybody remember what is the surface area of a sphere? Okay, so that's an assignment for me. Okay, let me try finding out an easier way to prove that. Let me just quickly check. Okay, yeah. So the volume is 4 by 3 pi r square, pi r cube, and surface area is 4 pi r square. Now, how that came into picture? Let me try finding out a simpler way to explain it. I don't want to go the calculus route. Let me find out something simple and keep that aside. I mean, keep me honest. Let next class. If I don't kind of touch upon that, if I don't find a simpler solution, I will let you know. If I just forget, just let me know. Okay. So this is the surface area and volume of a sphere. Again, when you talk about surface area, you're talking about how do you color the entire ball, change the color of the ball or the earth, or you have to make the earth green. Yeah. And then volume is 4 by 3 pi r cube. Have you guys heard about these formulas before, or something new is what you're coming across?
I've somewhat heard about these.
Yeah. So yeah, I will find out a simpler way to explain this, okay, or prove this formula. If I can do it without touching calculus, that is what I'll be looking for, okay. Otherwise, I have to do at least 3 to 4 classes to get you guys on board with the basic understanding of calculus, and then we can touch upon that. Okay, but yeah, since you guys don't have to prove most of the formulas, you'll be given the formula. You don't have to memorize them even. So that's why I'm taking the luxury of not explaining that right away. But this is an assignment for me. Okay. All right. So just to do a recap of what we have done so far, we looked at the basic understanding of surface area. We looked at the basic understanding of area of all the basic shapes, area, then we looked at what is the understanding of volume and surface area, and then we tried finding out the surface area and volume for things like cuboid, cube, right cylinder, right rectangular prism, whatever you call it. And then we just touched upon the surface area and volume of the cone and the sphere. Again, there are two things for me. I have just given you guys an opportunity to explore how do you find out the surface area of a cone, and I will find out an easier method to explain how the surface area and volume of a sphere is derived. Okay? And if I find a simpler one, if I don't, I'll let you guys know. Are we all on the same page with whatever I have discussed so far?
Yes.
No confusion? No doubt?
No.
Okay. Alright, now let's jump on to trigonometry. So, whenever we talked about one part of maths, right? We talk about algebra and we think that algebra is isolated. It is not. Each and every concept of maths that we learn or will learn in future, they are all relatable. There's nothing that you learn and you forget. You will end up coming back to the same concepts over and over again. So that is why when you would have learned geometry, then you would have learned, okay, what are different types of triangles. You learned about triangles being categorized into based on the sides, based on the angles. Based on side, you learned about the equilateral triangle, isosceles triangle, and scalene triangle. And then when you're looking at angles, you saw 3 types of angles: right angle triangle, obtuse angle triangle, and acute angle triangle. Now, many of you were not in that class when I was talking about the right angle triangle, where I mentioned that this right angle triangle, though it looks very cute, but it's not. This is the mother of one separate topic in maths, which is called trigonometry. So we'll touch upon the basics of what we know about right angle triangle, and then we'll do a deeper dive into trigonometry. So let's see what all we can cover today, and then in the subsequent classes we'll go to the next level of talking about trigonometry. But before I move on, one request to each one of you. I know I'm just going with my pace of teaching you guys what I want to teach, but then you all are in different grades. You have certain things being taught in the class. If you think that in the class you are lagging behind on certain things, there's something that is taught in the class which you are not aware of, and you would want me to touch upon those, please feel free to send me a message on WhatsApp saying that, sir, I would want this particular topic to be covered ahead of time. Like, I know some of you are planning to take SAT this year or the next year. So among those 13 units that we have, if there is any particular unit that you would want to learn ahead of my pace, just let me know a couple of days in advance so that I can tailor it to meet your requirements as well. Yeah. So that's an offer to all of you. So be it anything in the class where you feel that there's some concept that you're not clear about, just send me a WhatsApp message saying that in the upcoming class, can you teach this particular one? Or if you're planning to take a SAT exam ahead of time and you have certain units that you would want to cover beforehand, just let me know a few days in advance, so that way I can tweak my agenda for the class. Is that okay?
Yes.
Okay.
Yes.
Wonderful. Now, let's go to this cute looking triangle called right angle triangle. And again, some of the basics to recall. A right angle triangle is a triangle which has one of the angle and only one angle, which is 90 degree. Other triangles I don't care about. Right now I'm caring about a right angle triangle, or I'm qualifying this as a right angle triangle because it has one angle which is 90 degree or right angle, whatever you call it. So this is one thing. Other thing that we know about this triangle is, this is called hypotenuse. The side that is opposite to the largest angle. See, in this triangle if you see, this is 90 degree, and apparently this will be the largest angle of this triangle because the other two angles put together would be 90 degree. Yeah. So this, let's say this is A and this is B. A plus B would be 90 degree. So obviously this is the largest angle, right? So the angle opposite to the largest angle in the right angle triangle is called hypotenuse. Okay. Don't care about the spelling, it might be wrong. And the other two sides, this and this, are the adjacent sides, which is actually making the 90 degree. Are you guys with me so far? So there's another thing that we have learned, or we have explored in the previous classes, that is called Pythagorean theorem. What that says is a squared plus b squared equals to c squared. A is nothing but one of the adjacent side, b is nothing but the second adjacent side, and c is nothing but the hypotenuse. Meaning the square of the two sides, the sum of the square of the two sides, which is making 90 degree, will be equal to the square of the hypotenuse. Yeah. So you can choose how you want to remember this, but I'm sure you already have found your way. So Pythagorean theorem says a square plus b square will be equal to c square, or the sum of the squares of the two sides making 90 degree is equal to the square of the hypotenuse. This part is clear, right? Up to this much I can assume and move on. Okay. Some of you are very shy, don't respond. I'm assuming that being shy doesn't do any damage here, right? Feel free, feel comfortable, let me know. I mean, if there is something that you know versus you don't know, it's okay not to know. But it's not okay not letting me know what you don't know. Yeah? Alright. So this is, I'm just writing it down. A square plus B square equal to C square. Now let's look at trigonometry. What trigonometry says. Let's say this is an angle which I don't know what the value is. I'll use a variable, right? Variable is always my savior in the situation when I don't know something. If I don't know something, I'll just use a variable. I can use A, I can use B, I can use C, I can use alpha, beta, gamma, theta, whatever I like. Okay. I will just start with 60. This is not a variable. This is a known number. So I will always use a variable which will be an alphabet for assigning some value to things which are not known to us. So this, let's say this is my angle, this is theta. What will be the value of this angle? 90 minus theta? Because this is 90, this is theta, so this will be 90 degree minus theta. Yeah? And I don't know what theta is. Theta could be 5 degree, theta could be 45 degree, theta could be 89 degrees also, up to 89 degrees, or maybe 89.9999 degree. But it will not be 90, it will not be more than 90 either. Yeah? A moment of silence just to ensure everybody is with me. Yeah?
Yeah.
Alright. So here, now what trigonometry says is, they say, okay, fine, let's give it a name. Sine of a theta is equal to, if this is my angle theta, sine of a theta is equal to the angle opposite to this, the side opposite to this angle. So theta is this one, side opposite to this is what? A. This is my side opposite to this, A. Sine of theta is the side opposite to the angle divided by the hypotenuse. Yeah? Sine of theta, if I take this by as my angle, what will be the sine of this? It will be side opposite of this, B divided by C. Okay? So cut over. I mean, I'm just holding it a little slow. I'll come to that. What is the cosine of cos of theta? Will be the, if you are taking this as angle, cos of theta would be the side which is not the opposite side, but not the hypotenuse either. It will be B by the hypotenuse. Yeah? So cos of theta is adjacent side divided by hypotenuse. Sine of theta is opposite side divided by hypotenuse. There is something called tan. Tan theta will be equal to sine theta by cos theta. You can either look at it this way, or you can look at this as tan of the theta would be equal to opposite side divided by the adjacent side, A by B. Now I made an assumption here, tan theta equal to sin theta by cos theta. Let's see if this is the case. As per the definition, it says tan theta equals to the opposite side divided by the adjacent side, A by B. What I did was I jumped one step and said, okay, tan theta equal to sin theta by cos theta. Let's see if that is the case. What is the value of sin theta by cos theta? Sin theta is A by C. A by C. A by C divided by cos theta is B by C. What happens? It becomes A by C into C goes up, B comes down. Yeah? Tic-tac-toe. You got A by B. So sin theta by cos theta is equal to A by B, which is same as the value of tan theta. I'm sure everybody knows this. I'm just making sure that I don't move away from the basics before I go deeper into it. Are you guys with me so far?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay. Now, Now let's go to the next level of understanding. So far we have learned what is sine theta, what is cos theta, what is tan theta. There is a shortcut for that. They call it SOHCAHTOA. So it's SOHCAHTOA. Yeah. This stands for sine theta is opposite side A by hypotenuse C. Cos theta is adjacent side, that is B divided by hypotenuse. Tan theta is equal to opposite side divided by adjacent side, with this B. Same thing in a different way. So SOHCAHTOA, I mean, I'm sure 99% of you would be knowing this formula, so I will let you guys choose that to remember it. But any which way, I mean, the concept remains the same, it's just a way to memorize it. Now, do we know what is a complementary angle? If angle A, let's say angle A, and there is another angle B, let's say this is A and this is B. What do we know by the meaning complementary angle? What is called a complementary angle?
A right angle. Is it something that add up two numbers that add up to 90 degrees?
Yes. So I think that's what you were saying as well. So if there are two angles such that the sum of the two angles is 90 degree, that is called complementary. Okay, complementary angle. So they are called complementary angles. So if angle A plus angle B is equal to 90 degree, then angle A and B are called complementary angles. Meaning A complements B or B complements A to add up to become 90 degree. Yeah. So why I am talking about complementary angle all of a sudden, we'll come to that. Now look at this. Sine theta is equal to cos 90 degree minus theta. Now look at this, theta and 90 degree minus theta. This is theta, this is 90 degree minus theta. So here, same thing. These two together is making 90 degree. So this angle and this angle are called complementary angle here. Now I'm saying sine theta is equal to cos 90 degree minus theta. Why? Look at this. Now look at this angle. Sine theta is what? Sine theta is what? A by C. What is the value of cos 90 degree minus theta? So this is my angle now, 90 degree minus theta. Cos of this would be what? The base divided by hypotenuse. So base is A divided by hypotenuse C. See, this is same. What this means here is, when you are looking at, I think he would have heard it from me along with other kids in one of the class where I kind of made a table of sine, cos and tan values. Yeah, sine, cos and tan values. 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. So these are some standard angles for which we end up finding the value for it. Okay. So I have again tried to find out the value for these angles in one of the previous classes, and if whenever we feel like finding it out, we can certainly do that. But whatever we learned here, sine theta is equal to cos 90 degree minus theta. What that means is sine of any angle is equal to the cosine of the complementary angle. That's what we saw here, right? This is theta, this is 90 minus theta. These are complementary angles. Sine of this will be the side opposite to this divided by hypotenuse, A by C, will be equal to the cosine of the complementary angle. This is my complementary angle. The cosine of this will be the base divided by hypotenuse. So the base is A divided by C. So that's what I'm just proving one more time. Right? So this is something that you have to know. If somebody says sine of 45 degree will be equal to cosine of what? 45. Yeah, 90. So sine of 45 will be equal to cosine of 90 minus 45. Will be 45. Similarly, if I say sine of 10 degree will be equal to what value of cosine? What will you do? It will be cos of complementary angle. So 90 minus 10 will be equal to cos of 80 degree. Yeah? Okay. So the takeaway here is the sine of any angle is equal to the cosine of the complementary angle. That is what we will see here. Let's say sine of 0 degree. I am just telling you it is 0. The value of this is 0. Meaning, imagine this. This is your right angle triangle. I am saying this angle is very small. It's falling here. 0 degree. It's literally on this line. So, the opposite side's length is 0. 0 by hypotenuse. Whatever is the hypotenuse, that will be 0. So, sine of 0 is 0. Now, since you know the complementary angle of sine theta is equal to the complementary angle of cos theta. So, it will be cos of 90 degree will be 0. Since sine of 0 is 0, sine of 0 degree is equal to 0, because when I am saying 0 degree meaning this line is actually literally falling on this base. So this height is almost 0. Almost 0 meaning 0. I'm sorry? Oh, yeah, you're right. Yeah. So if you know sine theta value, you can find out the corresponding cos complementary angle value. So sine of 0 is equal to cos of 90 degree. If I say sine of 30 degree is 1 by 2, what will be the corresponding value for cos theta? I mean, what will be the which column it will fit in? That 1 by 2 will fit in where? Cos 60 degree. Are you guys with me, or you are just waiting for the class to get over? We have just 3 more minutes. 5 more minutes.
I understand, sir.
Yeah, you understand? So if sine 30 is 1 by 2, how is that found? We have done that in the previous class, and we'll come back to this one also. I will try filling this table for you guys, at least for few of the angles, so that way at least we can relate. Okay? So cos of 60 will be equal to 1 by 2. Let's look at one simple one, easy one, okay? Let's say I have to find out sine of 45 degree equal to what? If I find out value of sine 45 degree, we can find out the cos of 45 degree also, because both are same. Now sine of 45 degree, essentially what we are talking about is, there is a triangle, this angle is 45 degree, this angle is also 45 degree, and this is 90 degree. We are saying this side and this side are actually same. Yeah? That is how this is an isosceles triangle. Isosceles and right angle triangle. So this side and this side will be same, because these two angles are same. So let's say this is A, this is also A, and this is C. So here A square plus A square equals to C square. That means C square equals to 2A square, or C equal to root 2A. Now C is root 2A. Now let's find out sine 45 degree. Let's take this angle. Will be equal to the opposite side divided by hypotenuse. This is A. What is the hypotenuse? Root 2A. That becomes 1 by root 2. So we can fill 1 by root 2 here, 1 by root 2 here. Yeah. Similarly, we'll find out for the other two angles, and then we can continue with the remaining concepts that we want to learn for trigonometry. Any questions so far with respect to whatever we have learned?